Does our universe possess a distinct shape? This question marks the beginning of our journey into one of cosmology's most profound mysteries, the geometry of existence itself. We will investigate whether it is perfectly flat, like an endless plane, closed, like the surface of a colossal sphere, or open and curved, resembling a cosmic saddle. By leveraging modern physics and our most precise observational data, we can see how the very form of the universe reveals clues about its genesis, its ultimate destiny, and where you and I fit into this grand design. The quest for answers about the cosmos naturally leads you to ponder its origins and fundamental architecture. It is truly mind-boggling to consider how something so immensely vast and intricate could have arisen from a single point billions of years ago. The entire chronicle of the universe plays out like an epic saga on a timescale that defies human imagination, with every star, galaxy, and empty void contributing its own chapter to this immense story. During this exploration, you are confronted with the idea of the observable universe. To understand this, imagine yourself as an explorer navigating an immense jungle. No matter how far you travel, you eventually find boundaries that you simply cannot cross. In much the same way, the observable universe has its own set of limits, horizons that science has enabled us to measure and comprehend. Yet, have you ever paused to consider what might exist beyond those frontiers? Our innate human curiosity is limitless, and this drive to understand has empowered us to gauge even the most remote corners of the cosmos. Another concept that captivates our imagination is the constant expansion of the universe. If you visualize a balloon being inflated, you can see how any 2 points drawn on its surface will steadily move away from each other. The universe behaves in a similar fashion, with everything perpetually receding in a grand cosmic dance since the moment of the Big Bang, offering astonishing proof that our cosmos is dynamic and in a state of ceaseless transformation. The large-scale organization of the universe is just as awe-inspiring. Immense collections of stars, which we call galaxies, are not scattered randomly, but are grouped into clusters and superclusters, all interconnected by a vast cosmic web. Picture a gigantic celestial loom, where each thread is a string of galaxies, weaving an intricate tapestry that stretches far beyond the limits of our vision. This magnificent structure compels you to contemplate our own position within its seemingly infinite expanse. Despite our progress, two immense enigmas, dark matter and dark energy, continue to confound scientists. While they are invisible to our instruments, we have determined that they constitute the vast majority of the universe's total mass and energy. You can think of them as the silent darkness in a room. Their presence is not seen but is undeniably felt, exerting a powerful influence on everything we observe. The precise role they play in dictating the shape of the cosmos is still a major unanswered question. When you begin to speak about the shape of space itself, you enter the captivating realm of cosmic geometry. Were you aware that the universe might have the topology of a sphere, or perhaps even a donut? The specific way in which space curves and contorts directly influences how you perceive motion and distance across cosmological scales. This line of inquiry inevitably brings us to Albert Einstein's theory of general relativity, which completely revolutionized our comprehension of space and time. Black holes represent another compelling and mysterious cosmic phenomenon. Try to imagine a location in the universe where the force of gravity is so overpowering that absolutely nothing, including light itself, can break free from its grasp. Considering how black holes form and what part they play in the universe's overall structure, forces you to reflect on their fundamental nature and the ways they impact the star systems around them. The life cycle of a star is an equally remarkable process. From their formation within vast clouds of gas and dust to their cataclysmic demise as supernovae, stars truly serve as the architects of the cosmos. It is within these stellar furnaces that the elements making up everything you know, including your own body, are forged. Contemplating the role of stars in shaping the universe connects you directly to the very essence of our existence. Interactions among galaxies, such as mergers and collisions, are some of the most spectacular events in the cosmos. These galactic encounters do more than just alter the appearance of the galaxies involved. They also act as powerful engines for the birth of new stars and entire planetary systems. The form of our universe is in a constant state of flux, and every one of these collisions recounts a story of unending transformation. The creation of planets is another vital chapter in this cosmic history. The complex processes that give rise to planetary systems are deeply entwined with the overall shape and structure of the universe itself. Every single planet, moon, and asteroid you see is the outcome of a celestial dance that has been unfolding for many millions of years. Even the search for life beyond Earth is profoundly connected to the shape of the universe. You might ask how the cosmos's architecture could affect the likelihood of life emerging on other worlds. This very question impels us to investigate not only our own place in the grand scheme, but also the possibility that we are not the sole inhabitants of this immense void. As you venture into more advanced concepts like string theory, you begin to appreciate that everything might be fundamentally interconnected. This theoretical framework attempts to unify the basic forces of nature, proposing that the universe has a far more complex geometry than we can currently perceive. When you combine this with the principles of quantum cosmology, you start to grasp that the cosmos is a domain where the familiar rules of classical physics do not always hold true. Finally, it is crucial for you to think about the ultimate destiny of the universe. What fate awaits the cosmos in the distant future? The various theories describing how it might evolve and transform are as numerous as they are fascinating, and each one invites you to consider your own part in this unending narrative. The observable universe is a concept that naturally ignites human curiosity, but it's important to understand what it means. Using the analogy of a slowly inflating balloon, where each point on its surface is a galaxy, you can see how everything moves apart as it expands. This simple model helps explain the observable universe. It is the portion of the cosmos from which light has had time to reach us. This region that we can see, measure, and study currently extends for approximately 900 billion light-years in every direction. It's clear that the link between humanity and the cosmos is incredibly deep. Our evolving understanding of the universe doesn't just change our view of the world, it reshapes our perception of our own existence. By continuing to explore and learn more about the shape of the cosmos, you also journey deeper into self-discovery. This powerful curiosity is what propels us forward, encouraging our continuous exploration of the discoveries that lie ahead in the vast and enigmatic expanse. Have you ever wondered how we determine the universe's immense scale? The key is light itself. The starlight you see has journeyed for thousands, sometimes millions, of years to finally reach your eyes, effectively turning the night sky into a window to the distant past. This incredible vastness naturally leads to a profound question. If the universe is this large, does it actually have an edge? The question of a cosmic boundary is far from simple. While some scientific models propose an infinite expanse, others suggest a finite universe whose edge we could never physically attain. The situation is complicated further by the universe's continuous expansion, a process initiated by the Big Bang, which causes all celestial objects to move apart from one another. To measure this relentless expansion, astronomers analyze the redshift of light, a principle you can understand by thinking of a siren's changing pitch as it speeds away from you. Let's explore the origins of the vast cosmos we can observe. The entire story starts approximately 13.8 billion years in the past with a singularity, a point of immeasurable density that erupted in the event we call the Big Bang. In that initial instant, both space and time burst into existence and started to expand, paving the way for the formation of the first atoms, which were the fundamental building blocks for all future stars and galaxies. It helps to think of galaxies as more than just simple collections of stars. Picture an immense cosmic ocean where individual stars are like drops of water, and entire galaxies are the great currents and waves flowing within it. You can find some galaxies tightly packed into massive clusters, while others navigate the enormous voids of space in solitude. This variety and the interplay between all these cosmic structures is what gives the observable universe its breathtaking character. Our ability to see into the cosmos is fundamentally constrained by the age of the universe itself. Consequently, the deeper into space you peer, the more you are looking into the past. This limitation naturally raises the question of what exists beyond our observational horizon, and whether there are parts of the universe forever hidden from us. While the answer may be uncertain, this only fuels our drive to comprehend everything that lies within our reach. Each newly formed star and galaxy adds another chapter to the epic story of the cosmos, reminding us that the visible matter is only a fraction of a far grander tale. This quest for answers forces you to contemplate reality itself and wonder if our perception is merely the surface of something much deeper. For scientists, this is a realm ripe with discovery, where disciplines like astronomy, physics, and cosmology collaborate to unlock cosmic secrets, and every new mission pushes us closer to understanding. Yet, certainty is only achieved through rigorous verification and the repeatable confirmation of results. A single, faint glimmer in the night sky can spark a profound scientific inquiry. Researchers don't just passively observe. They formulate theories and run complex calculations, remaining prepared to amend their conclusions whenever new evidence comes to light. It is this systematic process that ensures our comprehension of the universe is constantly evolving. In the end, the observable universe represents far more than a mere object of scientific analysis. It is a mirror to our own inherent curiosity. Each question you or I might pose unlocks pathways to new investigations and revelations. The sheer scale of the cosmos inspires us to dream and speculate about what lies beyond our current knowledge. We are all participants in this cosmic narrative, each trying to find our own meaning on this vast stage. The next time you gaze up at the night sky, keep in mind that you are looking at much more than stars. You are observing a universe brimming with enigma, where each point of light carries a story from a bygone era. Pursuing knowledge about the cosmos shows us that even if we feel insignificant in its presence, the questions we ask are profound and deserving of the search for answers. The chronicle of our universe originates with the cataclysmic event we call the Big Bang. But what does that term truly signify? Consider an uninflated balloon. As you blow air into it, its surface expands. In a comparable way, the universe emerged from an infinitesimally small point and has been expanding continuously, allowing for the formation of the intricate cosmic web of galaxies, stars, and planets. To grasp the concept of this expansion, you must realize it isn't simply galaxies flying apart through empty space. Instead, the very fabric of space is stretching, a principle identified in the 1920s by the astronomer Edwin Hubble. He observed that galaxies are receding from us, and their speed is proportional to their distance, a relationship now known as Hubble's law. To put it another way, the universe's expansion isn't about galaxies traveling through a static void. It's the space between them that is actively stretching. This can be a difficult idea to visualize, so imagine raisins embedded in a rising loaf of bread dough. As the dough bakes and expands, all the raisins move apart from one another. This is an excellent analogy for how the universe functions, with expanding space carrying the galaxies along with it. The Big Bang is far more than a clever hypothesis. It's a theory underpinned by solid scientific proof. Perhaps the most persuasive evidence is the cosmic microwave background radiation, which is essentially a faint afterglow from the universe's infancy. This ancient light continues to permeate all of space, and its remarkably consistent temperature strongly supports the idea of a universe expanding from a singular, explosive origin. What evidence suggests that this cosmic expansion will persist? The key can be found by studying supernovae, the brilliant explosions that mark the death of massive stars. When astronomers analyzed these events in far-off galaxies, they discovered that the light from them was fainter than anticipated. This dimness implies that the galaxies are moving away from us at an ever-increasing rate, which leads to the startling conclusion that the universe's expansion is not just continuing, but accelerating. So what is the engine powering this accelerated expansion? To answer that, we must turn to more enigmatic concepts like dark energy, which is thought to constitute about 70% of the universe. Though we have yet to fully grasp its nature, dark energy appears to function as an anti-gravitational force, compelling galaxies to drift even further apart. Think of it as an unseen power that pushes everything outward instead of pulling it in. A cosmic puzzle that scientists are intensely focused on solving. The expansion of the universe also forces us to consider a compelling question. What will the cosmos look like in the distant future? As this expansion continues unabated, the galaxies you observe today might retreat so far from us that they eventually vanish from sight. This would happen because their light would need more time to reach us than has elapsed since they started moving away, presenting a rather bleak scenario of an increasingly isolated universe filled with invisible neighbors. Some cosmologists theorize this ongoing expansion could culminate in a future where the universe chills into a state known as the Big Freeze. In this outcome, all stars would eventually extinguish, leaving behind an immense and darkened void. In contrast, other scientists entertain the idea that the expansion could eventually halt and reverse, triggering a big crunch where all of existence collapses back into a singular, infinitesimal point. These competing theories underscore just how uncertain and thrilling our position in the cosmos really is. Embarking on this journey through space and time, it is fascinating to think about how the universe's expansion shapes our very understanding of life. As the cosmos stretches ever outward, it serves as a powerful reminder of our own smallness in the face of its boundless scale. And yet, despite this seeming insignificance, it is our innate curiosity and our relentless drive to comprehend our environment that have led to such extraordinary discoveries. The expansion is more than a physical process. It is a testament to our profound connection to the cosmos. This phenomenon invites us to contemplate our own existence, reminding us that every atom in our bodies was forged inside stars, and that we are built from the very same material as the universe itself. This viewpoint gives us a powerful incentive to keep exploring, to continue asking questions, and to dedicate ourselves to unlocking the mysteries that still await us. In this light, the expansion of the universe is also an inward journey into the unknown. With every new solution we uncover, a host of new questions emerges. Probing the depths of the cosmos is like working on a never-ending puzzle, one that perpetually motivates us to search and learn. As scientists press on with their research, The ultimate destiny of the universe will surely remain a captivating subject, likely holding many more surprises in store. The expansion of the cosmos is an astonishing reality, one that not only informs us about our origins, but also encourages us to envision the future. It is a constant reminder that while the cosmos may appear overwhelmingly vast and enigmatic, our thirst for knowledge is equally limitless. What new discoveries are waiting just over the horizon? And how will they transform our perception of both the universe and ourselves? Only time will provide the answers. But of one thing I am certain: human curiosity will continue to burn brightly, a solitary light against the vast darkness of space. What is it that truly gives the cosmos its form? To appreciate the sheer scale of the universe, you must first recognize the large-scale structures that define it, from the smallest star clusters to immense congregations of galaxies. Each of these components has a vital part to play in the cosmic arrangement. But how do they all connect, and what process organized them into the formations we observe today? Let's start with galaxies. These gigantic collections of stars, gas, and dust are like islands adrift in a cosmic sea, and our universe contains billions of them. The Milky Way, the galaxy you call home, is merely one of this countless multitude. These stellar islands also come in various forms. Some, like ours, are spiral-shaped, while others are elliptical or even irregular. Each galactic type tells a different story and possesses its own distinct set of characteristics. And what of the larger structures, like galaxy clusters? If you picture galaxies as individual bubbles, observing them on a grander scale reveals that these bubbles gather into clusters. These groupings are truly massive, often comprising hundreds or even thousands of galaxies. Furthermore, these clusters themselves are not isolated. They are organized into superclusters, creating a vast cosmic web that brings to mind an intricately woven tapestry. What incredible force could shape such colossal structures and bind them together? The answer is gravity, the invisible thread that weaves this cosmic fabric. It is the fundamental force that draws galaxies toward each other, enabling the formation and persistence of even larger structures. Gravity is not the only player in this cosmic design, however. Working alongside it is another component: dark matter. Though it remains unseen, dark matter performs a critical function in this cosmic ballet. So, what exactly is dark matter, and why is it so crucial for the universe's structure? Dark matter is a form of matter that emits no light or energy, which renders it completely invisible to us. We are confident it exists, however, because we can detect its gravitational influence. When observing a galaxy cluster, for example, we can measure the speeds at which its member galaxies are moving. These speeds reveal that there is far more mass present than we can see, and this missing mass, which we have termed dark matter, is what keeps the cluster from flying apart. As you zoom out to view the entire cosmic web, you notice the universe is anything but uniform. Immense voids exist between the filaments of galaxies and clusters, creating the impression of a cosmos woven from threads of empty space. This patchiness is a direct result of the universe's expansion and the way matter has settled over billions of years. As galaxies move farther apart, they leave behind these vast, unpopulated regions. The very shape of these cosmic structures also leads to some of the most profound questions about the nature of the universe itself. Is it finite, or does it stretch on infinitely? If you could embark on a journey through the cosmos, where would that voyage ultimately take you? Some theorists propose that the universe is geometrically flat, whereas others contend it might be curved, much like the surface of a sphere. This fundamental geometry profoundly influences our large-scale measurements of both space and time. As we delve into these cosmic structures, it's essential to recognize their active role in the universe's long history, shaping the very fabric of reality. Galaxies are not static objects, but dynamic systems in a state of constant evolution and motion. The interactions between them, particularly galactic mergers, give rise to entirely new cosmic formations. For instance, when two galaxies collide, they can merge to form a massive elliptical galaxy, a celestial body of a type that didn't exist before the event, illustrating how these grand collisions continually reshape the cosmos. It is truly remarkable to consider how these galactic interactions sculpt the universe over eons. Every collision represents a pivotal event that alters the cosmic architecture for billions of years, and the story of our universe is etched into the pathways of these celestial giants. If they could communicate, you can only imagine the epic tales they would share about their cosmic journeys and transformations. This line of inquiry naturally leads you to a deeper contemplation of the cosmos. Every star you see and every galaxy you observe through a powerful telescope stands as a testament to the universe's profound complexity and elegance. The shape of the cosmos is more than a topic for scientific debate. It serves as a powerful source of human inspiration and wonder, revealing a fascinating mixture of beauty, chaos, and order. As you continue to explore and learn more about the cosmos, you discover truths not only about the universe, but also about yourself and humanity's place within this immense tapestry. The sheer scale and form of everything around us serve as a reminder that although we may feel small, we are intrinsically part of something immeasurably vast and magnificent. Have you ever wondered what might be present throughout nearly the entire universe, yet remains completely invisible to you? We tend to envision the cosmos as a sea of brilliant stars, planets, and galaxies. The surprising reality, however, is that an even more fascinating component constitutes almost 95% of the universe: dark matter and dark energy. So, what exactly are they, and why do they hold such importance? Let's begin with dark matter. While you can neither see nor touch it, its presence is known, acting like an unseen force that shapes everything we can observe. Picture being at a party in a dark room. You can't see who is there, but you feel someone nudge a table. This is analogous to how dark matter functions. Its gravitational pull holding galaxies and galaxy clusters together and preventing them from flying apart. So, how can we be certain that dark matter exists if it eludes direct observation? Scientists have analyzed the rotational speeds of galaxies and found a significant discrepancy. If only the visible matter existed, galaxies would spin so fast that their stars would be flung into space. The fact that they remain intact suggests an enormous amount of unseen mass is providing the necessary gravitational glue. A fascinating realization that most of the universe is hidden from our view. Turning to dark energy, you encounter an even more perplexing phenomenon. It is best described as a mysterious force that is causing the expansion of the universe to accelerate. Imagine inflating a balloon. It grows slowly at first, but then expands more rapidly as you force more air into it. Dark energy works in a similar way, perpetually pushing the cosmos to expand at an ever-increasing rate. The scientific community has been working to solve the puzzle of dark energy since the discovery that the universe's expansion is accelerating. Observations of distant supernovae revealed this unexpected cosmic behavior, raising profound questions about the nature of the force behind it. While many theories exist, ranging from a property of space itself to a new kind of energy field, a definitive consensus has yet to be reached.
Consider for a moment a universe where gravity was the sole force governing the motion of galaxies. It would be an entirely different place. The existence of both dark matter and dark energy fundamentally alters our entire conception of the cosmos. Without these enigmatic components, the universe as you know it would likely collapse into a void almost beyond our comprehension. This quest for answers has driven scientists to formulate increasingly sophisticated theories. One leading hypothesis suggests that dark matter is composed of undiscovered particles, such as weakly interacting massive particles, or WIMPs. In simpler terms, these are particles that interact so faintly with ordinary matter that they are practically undetectable with our current technology, making their discovery an immense challenge. At the same time, dark energy presents a puzzle that seems to defy our intuition. The very notion of a force pushing the universe apart feels surreal, yet it is what the evidence suggests. What's even more compelling is the possibility that dark energy is connected to the cosmological constant, an idea originally introduced by Einstein in his theory of general relativity, potentially linking this modern mystery to a century-old concept. Ultimately, dark matter and dark energy are not merely curious additions to the cosmic inventory. They are the fundamental components that dictate the structure and ultimate fate of our universe. The interplay between these two forces will likely determine whether the cosmos expands indefinitely, or if it will one day reverse course and collapse in an event sometimes called the Big Crunch. The enduring mystery of the universe's composition serves as a powerful reminder of how much we have yet to learn. It instills a sense of humility before the sheer grandeur of the cosmos and inspires you to continue the search for answers. This is a scientific field in constant flux, filled with theories that challenge our perceptions and ignite our curiosity. It's crucial to understand that dark matter and dark energy are far from abstract ideas. They are the keys to deciphering the architecture of the universe. Every new discovery about these forces brings you a step closer to solving the ultimate mysteries of how the cosmos was formed and where it is ultimately headed. Probing these invisible forces remains one of the greatest and most exciting challenges in modern science. So, the next time your gaze turns to the night sky, consider this. Far beyond the familiar planets and shining stars, the cosmos holds profound secrets. Dark matter and dark energy are merely the first chapter in a grand narrative that continues to unfold. This collective quest to understand the universe's hidden components is an adventure that unites us, compelling you to look past the known and ask what else awaits discovery. The very shape of space is a captivating idea that challenges you to imagine what exists beyond the limits of your perception. Have you ever considered if the universe is perfectly flat, gently curved, or if it possesses some other bizarre, unknown geometry? The answer is not just a matter of curiosity. It holds deep significance for how we comprehend everything that surrounds us. While the universe's geometry might sound like an abstract concept, it is essential for deciphering the behavior of the cosmos on the largest scales. When we talk about the shape of the universe, we are referring to the large-scale distribution of galaxies and the very structure of space itself. Picture yourself in an immense ocean, where every galaxy is an island. The crucial question is, what is the shape of this cosmic ocean? The answer is directly linked to the curvature of space. In a flat ocean, the islands would be spread out uniformly. However, if the ocean were curved, some islands might cluster together, while vast empty waters would separate others. The form of the cosmos can be explored through three primary models: a flat universe, an open universe, or a closed universe. A flat universe behaves like an infinite, level plane where parallel lines will never cross. In an open universe, these lines would eventually drift apart, as if you were on a surface expanding outward forever. By contrast, a closed universe acts like the surface of a sphere, where parallel lines ultimately converge and meet, completing a loop.
How then can we determine which of these shapes our universe has? Scientists have employed various instruments, including observations of the cosmic microwave background, the residual heat left over from the Big Bang, to measure the universe's curvature. This ancient radiation serves as a kind of echo from the distant past, offering us a glimpse of the cosmos in its infancy. Based on these measurements, astrophysicists have concluded that the universe is, remarkably, almost perfectly flat. But what does a flat universe actually signify for you and me? It suggests that the total amount of matter and energy within the cosmos is in perfect balance with the force of gravity, holding its expansion in check. If there were slightly more matter, gravity would cause the universe to collapse back on itself. If there were less, the expansion would accelerate uncontrollably forever. Our cosmos exists on this delicate equilibrium, like an acrobat walking a tightrope between cosmic expansion and gravitational pull. What about the geometry of space on more familiar, smaller scales? In your everyday life, space appears to have 3 dimensions, but our universe actually possesses a far more intricate structure. Albert Einstein's general theory of relativity reveals that gravity doesn't just act on matter, it also warps the fabric of space itself. Imagine placing a heavy bowling ball onto a trampoline. The fabric stretches and sinks. In a similar way, massive objects like galaxies and black holes bend the space-time that surrounds them. The notion that space itself can be curved might sound peculiar, but it is fundamental to understanding phenomena like the bending of starlight as it travels near a massive object. This effect, known as gravitational lensing, enables us to see distant celestial bodies that would otherwise be invisible. It is as though the universe itself acts as a series of cosmic lenses, bending and redirecting light through the contours of curved space. As we explore these ideas further, it becomes clear that the shape of the universe is much more than a subject for academic debate. It has direct consequences for our understanding of the cosmos's history and its ultimate fate. Are we headed for a final collapse or an endless expansion? The answer likely lies in the geometry of space and the quantities of dark matter and dark energy it contains. Moreover, the shape of the cosmos influences how we might one day navigate it. If space is flat, our trajectories would be relatively simple and linear. But if it is curved, our journeys could become vastly more complex, affecting how we might travel through the universe and interact with other worlds. It is truly astonishing to consider that, despite our seeming insignificance in the vastness of space, our effort to understand the universe's shape connects us directly to the fabric of reality itself. Every discovery about cosmic geometry not only moves us closer to the truth about our cosmic home, but also prompts us to reflect on our own place on this grand stage. Ultimately, the shape of the universe serves as a powerful reminder that so much remains to be uncovered. As our technology progresses and observational techniques grow more sophisticated, we are bound to uncover even more incredible answers about the fundamental nature of the cosmos. Probing the structure of the universe is not simply a search for facts. It is a journey toward a deeper understanding of our own existence. So, the next time you find yourself looking up at the stars, remember that you are witnessing a vast ocean of possibilities, where the true form of the cosmos is one of the greatest mysteries still waiting to be solved. The theory of relativity stands as one of the pillars that completely transformed our conception of the universe. How is it possible for abstract concepts like time and space to be so deeply interwoven that their connection reshapes our entire perception of reality? The solution is found in the revolutionary ideas of Albert Einstein,
who in the early 20th century gave us an entirely new framework for understanding the cosmos. Relativity is built upon two core principles. First, that the laws of physics are identical for every observer, no matter how fast they are moving. This suggests that if you were on a high-speed train and tossed a ball forward, its movement would be indistinguishable from doing the same thing while standing perfectly still on a platform. But the picture becomes more complex when gravity is introduced. This brings us to the second principle, the idea that mass itself actually warps the fabric of space and time surrounding it. To help you visualize this, think of space as a vast, taut sheet. If you place a heavy sphere in its center, you'll notice the sheet sags and curves around it. This very curvature is what we experience as gravity. This analogy provides a clear image of how celestial bodies like planets, stars, and black holes fundamentally shape their cosmic neighborhoods. A massive object doesn't simply pull other objects toward it. Instead, it fundamentally changes the pathways those objects are compelled to follow through space. For instance, the Earth doesn't circle the Sun merely due to a straightforward gravitational tug. Rather, our planet is following the curve in space-time created by the Sun's immense mass. This is the very foundation of general relativity, a theory that reveals space and time are not rigid constants, but are instead flexible and dynamic. So, how does this flexibility impact our understanding of time? Relativity demonstrates that time is not a universal metronome ticking at the same rate for everyone. Consider the famous example of two twins. One stays on Earth, while the other journeys into space at a velocity approaching the speed of light. Upon the traveler's return, he would discover that he has aged significantly less than his earthbound sibling. This effect, which is known as time dilation, stands as one of the most mind-bending predictions of relativity theory. In essence, it confirms that the flow of time is personal and depends entirely on your circumstances. Now, let's turn our attention to what might be the most captivating objects in the cosmos, black holes. These phenomena come into being when a truly massive star depletes its nuclear fuel and collapses under the force of its own gravity. The resulting distortion of space and time is so profound that absolutely nothing, not even light itself, can break free from its grasp. This means that when you observe a black hole, you're looking at an absolute void in space, a region where the familiar rules of time and space operate in profoundly alien ways. However, black holes are far more than just cosmic devourers of matter. They also serve a critical function in the evolution of galaxies. Their immense gravitational influence can dictate the formation of new stars and shape the dynamics of an entire galactic system. What bearing does any of this have on us? Although these concepts might feel incredibly remote, relativity and black holes are deeply woven into the fabric of our existence and our comprehension of the universe on its most massive scale. Relativity offers a powerful framework for understanding the cosmos, explaining the ongoing expansion of the universe and the observation that galaxies are continually moving apart from one another. If space and time possess this inherent flexibility, it means the universe itself is in a perpetual state of flux and motion. Every galaxy, star, and planet is embarked on an endless voyage through a constantly transforming expanse of space. This isn't merely a matter of celestial bodies moving through a static background. Relativity encourages us to question the very structure of space itself. If space is capable of curving and bending, could it be that there are more dimensions than the ones we directly perceive? Some advanced theories propose the existence of hidden dimensions that are imperceptible to us, which would add an extraordinary layer of complexity to our model of the cosmos. As we explore the theory of relativity more deeply, we are faced with questions that fundamentally challenge our intuition. Could time travel ever be possible? How does our subjective experience of time reconcile with the objective reality of the universe? These are not questions with easy answers, yet relativity provides tantalizing clues about the nature of time and space that continue to fascinate both scientists and philosophers. Furthermore, relativity is not just a subject for theoretical physics. It has tangible applications that affect our everyday lives. For example, the global positioning systems, or GPS, in your devices must incorporate the effects of relativity to deliver precise location data. Without Einstein's theory, much of our modern technology would simply fail to operate as it does. In our ongoing effort to comprehend the cosmos, the theory of relativity acts as a guiding light on our journey. It reveals that the universe is a place of astonishing complexity and beauty, where the laws we often assume to be absolute can be fundamentally challenged. Each new discovery related to relativity not only enhances our understanding of the cosmos, but also prompts us to contemplate our own position within this vast and intricate reality. Einstein's theory of relativity is far more than a collection of equations. It is an open invitation to venture into the unknown, to question our assumptions, and to stand in awe of the sheer boundlessness of the universe. As we persist in probing the depths of the cosmos, it is vital to remember that every question we pose about time and space inches us closer to solving the ultimate mystery of existence. Black holes rank among the most mesmerizing and perplexing phenomena known to exist in the universe. But what are they, precisely? Put simply, a black hole is a specific region in space where the pull of gravity is so overpowering that nothing, not even light, can escape. This inherent property is what renders them invisible to our direct observation, though we can deduce their existence by observing their influence on nearby stars and gas. Think of a trap that, once sprung, hermetically seals every possible exit. This is an effective analogy for how a black hole functions. It generates a gravitational field so intense that any object venturing too close is captured irreversibly. This process begins when a star of sufficient mass burns through its fuel, causing its core to implode under its own immense gravitational force. The result is akin to a colossal object being crushed down to a point of infinite density, where all of its mass becomes concentrated. So, what actually occurs inside a black hole? The answer to that question is profoundly mysterious. Once you cross the event horizon, the definitive boundary of no return, you enter a reality where the laws of physics as we understand them no longer apply. At that threshold, space and time become warped in ways that we have yet to fully grasp. It would be like stepping through a doorway into a realm governed by an entirely new and unknown set of rules. The strange nature of black holes has prompted many scientists to speculate whether they could function as gateways to other locations in the universe. While this concept certainly sounds like something from science fiction, certain theories do propose that connections between black holes and other cosmic regions, often called wormholes, might be possible. Nevertheless, this idea remains purely in the realm of speculation, as we currently have no tangible evidence to support it. One of the most captivating characteristics of black holes is their capacity to devour matter. When a star or a cloud of gas ventures too close, it is drawn into a spiral, forming a swirling band of material called an accretion disk. The friction within this disk generates incredible heat, causing it to blaze with intense radiation. This very radiation often allows astronomers to pinpoint the location of a black hole, even though the object itself remains invisible to us. But you might wonder why these cosmic phenomena should matter to us. The answer is straightforward. They are integral to the very architecture of the universe. Black holes are found at the heart of most galaxies, ours included, and it is thought that their immense gravitational pull is what helps bind stars and other celestial objects together. So, While they might seem like dark, menacing voids, they are in fact crucial for cosmic order. Black holes also provide us with profound lessons about the fabric of space-time itself. As something gets closer to a black hole, time for that object appears to slow down from the perspective of a distant observer. This effect, which is known as time dilation, stands as one of the most striking predictions of Albert Einstein's theory of relativity. If you were on a spaceship approaching a black hole, what would feel like mere minutes for you could correspond to many years passing back on Earth. Some of these objects, called supermassive black holes, are genuine titans of the cosmos. Situated at the centers of galaxies, their mass can be millions or even billions of times greater than our sun's, and their formation is still a significant puzzle for scientists. How could such colossal entities ever come into being? Current theories propose that they might have evolved from smaller black holes, growing over billions of years through mergers and the continuous accumulation of matter. As researchers delve deeper into these cosmic enigmas, they have discovered that black holes are not all uniform. They exist in various sizes and originate from different processes. For instance, stellar black holes are the remnants of collapsed massive stars, whereas others might be born from the collision of stars within binary systems. Each distinct type of black hole offers unique clues that help us piece together the history of the universe. Furthermore, the investigation of black holes has spurred significant progress in our comprehension of fundamental physics. The ongoing search for a single theory that can reconcile general relativity with quantum mechanics raises critical questions about how black holes function at a quantum level. This leads to profound dilemmas, such as whether information can genuinely be destroyed inside a black hole, sparking vigorous and fascinating debates throughout the scientific community. In the field of astronomical observation, the Event Horizon Telescope project achieved a historic milestone in 2019 by capturing the very first image of a black hole. This picture, showing the black hole at the core of the M87 galaxy, was a landmark moment in astronomy. It furnished visual confirmation of their existence and has unlocked new avenues for scientific inquiry, bringing us closer than ever to understanding their secrets. Beyond their role as subjects of scientific study, black holes encourage us to reflect on our own existence. They symbolize the current boundaries of our scientific understanding and serve as a powerful reminder of just how much we have yet to learn about the universe we call home. In exploring these mysterious remnants, we find ourselves at the crossroads of science and philosophy, questioning our grasp of time, space, and reality itself. Human curiosity is the engine that drives us to comprehend the unknown, and black holes represent one of the greatest unresolved questions in the vast chronicle of the cosmos. Each new discovery brings us a step closer to solving the universe's riddles, yet every answer invariably gives rise to new questions. On this expedition into the unfamiliar, black holes are among the most compelling destinations, reminding us that no matter how much knowledge we acquire, there will always be new mysteries to challenge and inspire our continued exploration. The life of a star is a remarkable phenomenon that offers a direct connection to the cosmos. Have you ever considered how these immense spheres of plasma are born, how they live, and how they ultimately die? Stars are much more than mere specks of light in the night sky. They are cosmic forges that create the very elements composing everything we know, including ourselves. But what exactly is the life cycle of a star? To understand this, we must first envision an enormous cloud of gas and dust drifting through space, a structure known as a nebula, which is where this celestial story starts. Deep inside this nebula, gravitational forces begin to pull particles of gas and dust toward one another. As this material clumps together, both pressure and temperature escalate, eventually creating a searingly hot core. You can think of this process like compressing dough in your hands. The more you squeeze it, the warmer it becomes. In time, this core becomes so intensely hot that it ignites nuclear fusion, the very process that sparks a star into existence and makes it shine. Once a star enters its fusion stage, it begins to radiate light and heat. But what is actually happening? Nuclear fusion is the mechanism by which atomic nuclei merge to create new, heavier elements. For most of its life, a star is busy converting hydrogen into helium in its core, much like ingredients in an oven are transformed into a finished meal. This phase, however, is not indefinite, and the star will eventually exhaust its primary supply of hydrogen fuel, leading to the next chapter in its existence. When a star's hydrogen is depleted, it transitions into a new phase of its life cycle. It starts to fuse helium into even heavier elements, such as carbon and oxygen. As these new elements are forged, the star undergoes a dramatic expansion, transforming into what is known as a red giant. You can visualize this as a balloon being inflated to the point where it looks ready to pop. This expansion is a critical part of a star's evolution, as it profoundly impacts its cosmic surroundings. Throughout this period, a star can undergo a series of spectacular events. Often, its outer layers are cast off into space, forming a breathtaking structure called a planetary nebula. These nebulae are like celestial works of art, composed of glowing gases and dust that gradually disperse. But what becomes of the star's core after this happens? Its destiny is ultimately determined by the star's original mass. For smaller stars such as our Sun, the core will shrink into a white dwarf, a hot, dense ember that will slowly cool and fade over eons. For much more massive stars, however, the final act is destined to be far more dramatic. Massive stars can culminate in a supernova, one of the universe's most formidable explosions. For a short time, this cataclysmic event is so brilliant it can eclipse the light of its entire home galaxy. After such an immense detonation, the star's core might collapse into an incredibly dense object called a neutron star. Alternatively, if the core's mass is sufficient, it could form a black hole, a cosmic anomaly so powerful that it ensnares everything nearby, including light itself. It is truly incredible to consider how something that once shone brightly can become an object from which nothing can escape. However, a star's story doesn't conclude with its demise. Supernova explosions are responsible for dispersing the heavy elements forged during the star's existence throughout the cosmos. Materials such as carbon, oxygen, and iron are fundamental to the creation of new stellar systems and, eventually, new planets, meaning every star effectively contributes to the birth of future celestial generations. Have you ever considered that the very atoms composing your body were likely forged inside a distant star? This continuous cycle of stellar birth, life, and death is what sculpts our universe. Every star you observe in the night sky is an active participant in an epic narrative that has been developing over billions of years. Grasping this cycle deepens our appreciation for the cosmos and forges a direct link to the history of the universe itself. So the next time you look up at the stars, remember that each one has a unique story and that their journey is profoundly connected to our own. Stars are much more than simple points of light against the dark expanse. They are the foundational pillars of creation and the architects of the cosmos. And while their lifespans are brief on a cosmic scale, their legacy is eternal, feeding the ongoing life and evolution of everything in existence. Galaxies can be thought of as immense stellar islands floating in the boundless ocean of space. But what occurs when these islands drift too close? Instead of merely passing one another, they can get caught in a gravitational dance that completely transforms their shape and structure.
The collision of galaxies is a remarkable process, offering a window into how the universe is in a state of constant change.
Picture two seemingly tranquil galaxies whose paths over millions of years are set for an unavoidable intersection. As they approach, their gravitational fields start to interact, behaving like colossal magnets pulling and pushing on each other. This interplay can trigger a series of truly spectacular cosmic events. While the individual stars within them are too far apart to actually collide, their orbital paths are altered in dramatic and unforeseen ways. When galaxies crash into one another, they not only have the potential to merge, but can also ignite a wave of new star formation. The interaction between them can compress vast clouds of gas, establishing ideal conditions for fresh stars to be born. It is a process where, out of the apparent chaos of a galactic collision, stellar life can find a way to begin anew, demonstrating the universe's regenerative power. This process also applies to even larger formations, like clusters of galaxies. When multiple galaxies converge into a single cluster, their collective interactions weave a cosmic web of even more massive structures. Studying these events helps us understand not only how individual galaxies are formed, but also how they are interconnected across the vastness of space, creating the large-scale architecture of the universe. However, not all galactic encounters lead to a seamless merger. Sometimes, the gravitational tug-of-war distorts their original forms, stretching and twisting the galaxies into bizarre new shapes. This deformation process can result in breathtaking cosmic features, such as tidal tails, which are long, extended streams of stars and gas that trail away into the void. These events raise a fascinating question. What can these collisions reveal about the history of the universe? Every galactic encounter serves as a chapter in a cosmic chronicle. By analyzing the remnants of these interactions, astronomers can piece together the story of cosmic evolution, learning how galaxies have transformed over eons and shaped the universe we observe today. A particularly compelling result of these collisions is their contribution to the formation of supermassive black holes. As galaxies merge, vast amounts of matter can funnel toward the center, creating the necessary conditions for a gigantic black hole to emerge. This central black hole can then exert its influence over the entire galaxy, modifying its shape and regulating the pace of star birth and death in a perpetual cycle of creation and destruction. It is crucial to understand that these collisions are not rare occurrences, but are a fundamental part of cosmic evolution. Throughout the universe's long history, such events have been instrumental in building the structures we now see. Without these interactions, the cosmos would look entirely different, like an unfinished puzzle whose pieces were never brought together to form a complete picture. Modern instruments, such as the Hubble Space Telescope, have given us the ability to witness these collisions with extraordinary clarity. The images they capture are like snapshots of an ongoing cosmic dance, showcasing the breathtaking beauty and complexity of the universe. By studying these interactions, scientists collect invaluable data that refines our understanding of how the cosmos functions, while also inspiring us to contemplate our own position within this grand, dynamic stage. In stark contrast to our brief lifespans, the universe evolves on a scale of billions of years, a comparison that truly highlights the ephemeral nature of our existence within the vastness of the cosmos. Have you ever wondered what destiny awaits galaxies following a cosmic collision? When two of these immense structures merge, they don't just annihilate each other. They can form a single, larger galaxy, embarking on a new shared existence. This seemingly chaotic event can actually initiate a fresh era of stability and stellar creation, proving that every collision is as much a new beginning as it is an end. The next time you find yourself gazing at the night sky, I want you to imagine the galaxies in perpetual motion, engaged in a timeless cosmic ballet of spinning and dancing. Every point of light you observe could belong to a galaxy whose present form was sculpted by past encounters. A powerful reminder that absolutely nothing in the universe is ever truly static. The very structure of the cosmos is a chronicle of its own history, a story rich with collisions, mergers, and ceaseless transformation, demonstrating that the universe is a dynamic and living place where every interaction has meaning. The creation of planets is an equally awe-inspiring process that serves as a testament to the dynamic and marvelous nature of our universe. But what is the actual mechanism behind the birth of a planet? To grasp this, you must first journey with me to the immense, frigid expanse of a nebula, for that is where the story truly begins. Picture a colossal cloud of interstellar gas and dust, where the force of gravity begins to act like a cosmic magnet, relentlessly pulling all the particles toward a common center. Over vast stretches of time, this cloud collapses inward under its own immense weight, giving rise to what is known as a protoplanetary nebula. Within this swirling environment, particles of dust start to collide and adhere to one another in a process that transforms chaos into creation. As these tiny particles continue to merge, they gradually form small celestial bodies, referred to as planetesimals, which are essentially the fundamental building blocks of our universe. These planetesimals then persist in colliding with each other, combining their masses to forge even larger objects. This stage can be incredibly violent and turbulent, yet it is absolutely essential for the construction of planets, moons, and asteroids. Gravity, the very same force that anchors you to the Earth, serves as the master conductor in this symphony of cosmic formation. What ultimately dictates the size and shape of a newly forming planet is a delicate equilibrium between its gravitational pull and the outward push of gas pressure. As a celestial body accumulates more mass, its gravity intensifies, allowing it to attract even more material, which can fuel its growth and lead to the development of a substantial atmosphere. Of course, not all planets end up being the same. Some mature into massive gas giants, while others become smaller, rocky worlds. This divergence is largely determined by their location. Planets forming closer to their star, like Mercury, Venus, Earth, and Mars, exist in a warmer zone where heavier elements such as iron and silicates condense. In contrast, gas giants like Jupiter and Saturn take shape in the frigid outer reaches of a solar system, where they can freely accumulate vast quantities of hydrogen and helium. The emergence of a planetary system is not a series of isolated events, but rather an intricate cosmic dance. As planets form and grow, they exert a powerful influence on their surroundings, with their gravity attracting or repelling other bodies, and thereby sculpting the architecture of the system as a whole. Just imagine residing in a system where planets are in constant flux, altering their orbits and their very forms as part of a grand, coordinated performance. This is also where asteroids and comets enter the narrative, as these smaller bodies are the leftover debris from the planet-building process. Remarkably, some of these remnants may eventually collide with planets, delivering materials that could be vital for the emergence of life, which raises the profound idea that even a small asteroid could serve as a vessel for life's essential ingredients. The story of planet formation doesn't conclude once the planets themselves are fully formed. Over millions of years, they continue to change and evolve. On Earth, for instance, the process of plate tectonics has dramatically reshaped our continents and oceans over geological time. Could planets in other star systems possess their own versions of this geological engine? Scientists are discovering the answer is yes, suggesting we are not unique in this cosmic dance. As our exploration extends beyond our own solar system, we have identified thousands of exoplanets, worlds that orbit distant stars. Some of these discoveries appear Earth-like, while others are entirely alien, showcasing the sheer diversity inherent in planet formation. This growing catalog of worlds proves that the universe is endlessly creative, with countless possible pathways for planets to form and evolve. The quest for life on these other worlds is intimately connected to understanding how they were created. A planet situated within its star's habitable zone, where conditions might allow for liquid water, is a prime candidate for hosting living organisms. Astronomers investigate these worlds by studying their atmospheres, their chemical compositions, and their distances from their parent stars. Consequently, planet formation transcends a mere physical process. It holds the key to discovering whether we are truly alone in the universe. It's captivating to realize that by studying the birth of other worlds, we gain deeper insights into our own home. Earth, with its incredible biodiversity and varied landscapes, is the product of a cosmic history stretching back billions of years, and every mountain, ocean, and continent tells a piece of that epic story. So, the next time you gaze up at the starry sky, remember that each of those stars could be the center of its own planetary system, each with a unique tale to tell. The process of planet formation serves as a powerful reminder of the cosmos's complexity and its remarkable ability to bring order from chaos. Every planet, every moon, and every asteroid is a player in a vast and magnificent spectacle. As we continue to explore and find new worlds, each discovery seems to raise even more questions, prompting us to wonder what else awaits in the boundless expanse of space, and what secrets the formation of new worlds has yet to reveal. Human curiosity is a relentless force, and the cosmos is brimming with mysteries that are simply waiting for you to uncover them, which naturally leads to the ultimate question. What if we find out our universe is not the only one? When you look at the cosmos, filled with its innumerable stars and planets, it is natural to wonder about life beyond our world. This question is not new. For millennia, people have stared into the night sky, contemplating whether other intelligent beings might be doing the same. The stars visible to your naked eye are just a tiny sample of the universe's total, and orbiting many of them could be planetary systems much like our own. This raises the question of what specific requirements are needed for life to emerge, and whether, somewhere in a remote part of our galaxy, another species is pondering our existence. Scientists approach this by defining a habitable zone, the specific orbital distance from a star where the environment could support life as we understand it. This ideal region is not static. Its location and size change based on the unique properties of each individual star. A simple way to visualize this is to think of every star as a lamp, with the habitable zone being the area where the light is perfect for growth. Outside this band, the environment becomes hostile, plunging into either the profound chill of deep space or the searing temperatures close to the star. Thanks to breakthroughs in astronomy, we have identified thousands of exoplanets, and a number of these worlds orbit within their stars' habitable zones, significantly boosting the odds that life could exist on them. Simply finding a planet in the right place is not enough. How can you confirm if life is actually there? The solution is to hunt for biosignatures, which are telltale chemical or atmospheric indicators of biological activity on these remote worlds. This quest is not confined to planets resembling Earth, as researchers are now turning their attention to moons within our own solar system, like Europa and Enceladus, where vast liquid water oceans are hidden beneath frozen crusts. A compelling theory suggests that microbial organisms, much like those on our own planet, might thrive within these concealed oceans, a whole ecosystem awaiting our discovery. In a different approach, radio astronomers are systematically listening for signals from intelligent alien civilizations. Projects like the Search for Extraterrestrial Intelligence, or SETI, have meticulously monitored millions of radio channels for any transmissions that defy natural explanation. And while nothing definitive has been found, the persistent effort to listen is a crucial part of the process. Determining whether we are unique in the cosmos carries enormous weight, both scientifically and philosophically. The discovery of any form of life would fundamentally alter how you see yourself and humanity's position in the universe, potentially ushering in a new era for our species. Yet, we must also cautiously reflect on the potential consequences of making contact, as human history provides many examples of cultural encounters that did not end peacefully. The very structure of the universe itself plays a role in the potential for life to exist. The way galaxies are arranged across vast cosmic webs results in some areas being more conducive to habitability than others. Moreover, mysterious forces like dark matter and dark energy, which constitute the majority of the cosmos, are instrumental in sculpting galaxies and star systems, serving as a powerful reminder of how intricate and enigmatic the universe truly is. In this grand design, everything appears to be interconnected, with each cosmic component potentially contributing to the circumstances that foster life. As you contemplate the universe's structure, it becomes clear that the quest for alien life has also become a profound inquiry into our own origins and purpose. By exploring the cosmos, you gain deeper insight into what it means to be human. And each new finding moves us nearer to answering that ultimate question. Are we alone? This immense search for knowledge unites the fields of science, philosophy, and space exploration in a common cause. Advanced instruments like the James Webb Space Telescope enable us to look deeper into cosmic history, providing a clearer picture of the environments where life could emerge. Every fresh piece of data broadens our understanding, bringing us one step closer to grasping the universe's fundamental structure and its relationship to life. The idea of extraterrestrial life, from microbes on a frozen moon to sophisticated societies in faraway star systems, is not merely the stuff of science fiction. It represents a tangible possibility that compels us to push forward with our explorations. So, when you glance up at the night sky, consider that each star could be home to narratives, aspirations, and types of life that are currently beyond your imagination. Therefore, the next time you find yourself looking at the stars, reflect on the sheer immensity of the cosmos and the endless potential it holds. This quest is more than a simple hunt for other creatures. It is an expedition toward a deeper understanding that could reshape our very existence and our role in the universal order. The fundamental nature of the universe remains an unsolved puzzle, but its mystery drives us to continue exploring and questioning, leaving us to wonder what marvels the future might reveal. Let's delve into string theory, a concept so captivating it sounds like it originated in science fiction. Yet it is a central pillar of contemporary scientific inquiry. Picture a universe where the fundamental building blocks are not distinct particles like atoms and electrons, but rather infinitesimal, vibrating filaments of energy. These strings are so unimaginably small that they would remain invisible even under the most powerful microscope conceivable. How then could these microscopic strings govern the entire world you see? The answer lies in their vibration. They resonate at various frequencies, much like the strings on a musical instrument. Each unique frequency corresponds to a different elementary particle, meaning that electrons, quarks, and photons are all just different expressions of these strings, vibrating in distinct ways. It is a truly remarkable idea that everything in the cosmos might be the product of these resonant frequencies, and string theory's ambition extends beyond explaining particles to providing a single, unified framework for all of nature's fundamental forces. At present, our understanding of physics is built upon four fundamental forces: gravity, electromagnetism, and the strong and weak nuclear forces. Have you ever considered what it would mean if we could unify all of them into a single, cohesive, theoretical framework? This ambitious goal is exactly what string theory endeavors to achieve, much like assembling the scattered pieces of a cosmic puzzle. However, this theory presents a significant condition. For its mathematics to be consistent, it requires the universe to have more dimensions than we are familiar with. Beyond the 3 dimensions of space and the 1 dimension of time that we experience, string theory proposes a total of 10, or in some variations, even 11 dimensions.
How is it possible for you to even begin to conceptualize something that you can neither see nor directly perceive? A helpful way to think about this is to imagine a common garden hose. When you view it from a great distance, it looks like a simple one-dimensional line. But as you approach it, you realize it possesses a third dimension in its thickness. In a similar fashion, these extra dimensions might be incredibly small and curled up, effectively concealed from our senses.
The real question is why these theoretical strings and hidden dimensions should matter to you at all. The answer is profound. If string theory proves to be correct, it holds the potential to resolve some of the most fundamental mysteries about our universe. We might finally learn what occurred before the Big Bang, or how gravity operates on the quantum scale, a breakthrough that could completely reshape our knowledge of physics. Within the field of cosmology, string theory offers some equally fascinating possibilities. It could potentially explain phenomena such as dark energy, which is the enigmatic force seemingly causing the universe's expansion to accelerate. By gaining a deeper insight into the behavior of these strings, we could uncover the true nature of this energy that constitutes the majority of the cosmos. Furthermore, string theory may serve as our guide to comprehending the multiverse, a hypothesis suggesting that our universe is just one among many. Each of these other universes could be governed by its own unique set of physical laws and dimensions, resulting in an endless array of distinct realities. Isn't it a mind-bending thought that our existence might be just one of countless cosmic possibilities? Despite its elegance, string theory faces considerable skepticism. A number of scientists point out that no experiment has ever produced direct confirmation of its claims. A scientific theory typically needs empirical evidence to gain acceptance, but so far, string theory has remained primarily within the domain of theoretical mathematics, prompting debate over whether an untestable idea can be considered truly scientific. One of the most captivating elements of string theory is its overlap with philosophy, as it compels us to question the very fabric of reality, time, and space. If it turns out that these vibrating strings are the fundamental building blocks of everything you observe, what does that imply about the nature of being real? This is a query that has captivated thinkers for millennia. As researchers persist in developing and refining string theory, new concepts and methods are continuously coming to light. Some cutting-edge theories are now merging ideas from string theory with quantum mechanics, which may pave the way for new insights into the universe's workings. This ongoing quest for a unified theory could very well represent the next major advancement in our cosmic understanding. Even though string theory is still a theoretical construct, its power lies in its capacity to kindle our curiosity and sense of awe about the cosmos. Every new piece of research and each discovery brings us a step closer to solving the great puzzles of existence, So, the next time you gaze up at the night sky, consider the possibility that everything you see is composed of vibrating strings, all interconnected in a grand symphony of cosmic wonder. In essence, string theory stands as a complex and promising concept that attempts to unite the basic forces of nature and illuminate the essence of the universe. While a great deal is yet to be proven, its pursuit challenges our intellect and pushes the frontiers of what we know. This brings us to quantum cosmology, an incredible meeting point where the physics of the smallest particles, quantum mechanics, intersects with the study of the largest scales, cosmology.
Quantum mechanics, which is often characterized as a world of strangeness and counterintuitive rules, proposes that subatomic particles like electrons and photons lack definite properties until the moment they are measured. In a way, the act of observation itself is what solidifies their reality. This might sound peculiar, but you can think of it like searching for a friend at a crowded party. Until you actually spot them, their exact location remains uncertain, as they could be anywhere in the room. So, what unfolds when we attempt to apply these quantum principles to the immense scale of the entire universe? Quantum cosmology ventures into this fascinating territory, proposing that the very fabric of space and time might be shaped by these quantum behaviors. You could visualize the universe as a massive ocean, with each particle acting as a single drop of water. The movement of these drops creates waves, and their collective interactions could influence the overall form of the ocean itself. One of the most compelling ideas to arise from this synthesis is the notion of the multiverse. If the quantum realm allows for every potential outcome to exist at once, could this imply the existence of parallel universes, each containing a different version of our reality? You could picture a book where every page depicts a separate universe. Each choice you make could theoretically lead you down a completely different narrative path within that book. This leads to the captivating concept that space and time are not fixed absolutes, but can instead be molded by the presence of energy and matter. In this view, the universe is less of a static stage and more of a dynamic canvas, constantly being repainted as particles move and interact. This forces us to reconsider the nature of time itself and question whether the past, present, and future are as straightforward and linear as you've always believed. Quantum cosmology also compels you to question the very nature of gravity. The force that feels so reliable and consistent in our daily lives might act in entirely unpredictable ways on a quantum scale. Scientists are actively working to solve the puzzle of how gravity influences particles in superposition, those that can exist in multiple locations simultaneously. This exploration naturally leads to one of physics' greatest ambitions, the unification of general relativity and quantum mechanics into a single, comprehensive theory that could revolutionize our cosmic understanding and pave the way for unimaginable new technologies. Delving into quantum cosmology also encourages you to contemplate your own existence. When you view the universe as a tapestry woven from probability and potential, it forces you to ask what your role is within it. You are an integral component of this immense cosmic drama, both affecting and being affected by the intricate dance of subatomic particles, suggesting that even our deepest emotions are expressions of the quantum processes that define reality. Within this framework, the age-old question of our solitude in the cosmos acquires a fresh dimension. The existence of multiple universes raises the possibility of conscious entities dwelling in realities forever beyond our reach. This idea profoundly enriches the search for extraterrestrial life, reframing it as an exploration of just one potential reality among a countless number,
each governed by its own unique principles. Furthermore, quantum cosmology proposes that the vacuum of space is far from empty. On the quantum level, this void is actually a seething environment where virtual particles constantly pop into and out of existence. This phenomenon forces you to challenge your very concept of emptiness, implying that what you perceive as nothingness might, in fact, be a crucial element in the fundamental architecture of the cosmos. Ultimately, quantum cosmology reveals a universe brimming with profound mysteries and boundless potential, inviting you to re-examine your perception of reality and investigate the deep connections between the infinitely small and the infinitely large. As you follow these explorations, remember that each new discovery turns another page in our cosmic story. Every answer we uncover only leads to more questions. And on this journey, your curiosity serves as the most reliable guide, offering a vision of a universe that is a marvel of intricacy and beauty.
The notion of the multiverse might sound as if it were lifted from a science fiction novel, yet in cosmology, it stands as one of the most enthralling and controversial theories. I want you to imagine that our entire universe, with its trillions of stars and galaxies, is just one bubble in a vast ocean of other bubbles, each one representing a different universe. The question that immediately follows is, what could be inside these other realms? And are they similar to our own, or governed by entirely different physical laws? A universe such as ours possesses a very specific set of characteristics, including its quantities of matter, energy, and the physical laws we understand. But if you entertain the possibility of other universes, a gateway opens to countless other scenarios. There could be realities where gravity is much stronger, or where elementary particles have entirely different properties. Can you envision a place where time itself flows differently? Or a universe where life as you know it would be impossible? This idea of multiple universes also introduces a fascinating question about the ultimate destiny of our own cosmos, suggesting that its collapse could trigger the birth of a new one in an endless cycle. To help you grasp this concept more clearly, I often use the analogy of a massive tree where each branch represents a different universe. Some branches are thick and robust, while others are thin and fragile. Some may have leaves symbolizing stars and planets, while others remain barren and empty. This metaphor helps to visualize how the multiverse could be structured, with some universes thriving, while others simply fade into darkness. So, how did physicists even arrive at the conclusion that a multiverse might exist? The strange and captivating field of quantum mechanics plays a pivotal role. At the subatomic level, particles appear to exist in multiple states at the same time, which has led some scientists to propose that every possible outcome of a quantum event results in the creation of a new universe. By this logic, every decision and every event could be spawning new realities in a vast ocean of possibilities. Of course, the multiverse theory is not without its critics. Many scientists argue that without any means to observe or measure these alternate universes, the concept cannot be considered truly scientific. This leads to a fundamental debate within the philosophy of science. Is an idea's intrigue alone enough for it to be taken seriously? This tension highlights the classic conflict between what we can empirically observe and what we can possibly imagine. One of the most captivating questions that arises from all this is whether we could ever interact with these other universes. Some theorists propose that if you could discover a method for jumping between realities, you might experience entirely different forms of existence. This may sound like the plot of a science fiction film, but the advanced mathematics behind string theory and other theoretical models is exploring these very concepts. I ask you to imagine, for just a moment, that every decision you make in life,
from the most trivial to the most significant, actually creates a new universe. In one reality, you chose to stay home, while in another, you went to a party that changed your life forever. This perspective, where each small change could spawn an entirely alternative universe, is a thought that you might find both liberating and terrifying.
The idea of a multiverse forces you to reconsider your own existence. If countless versions of you exist across other universes, it raises the question of what truly makes your identity unique. The search for purpose and meaning grows far more intricate when you entertain the notion that you might be just one of many possible variations. While this realization can be disorienting, it also paves the way for new perspectives on who you are and where you fit into the grand scheme of the cosmos. As our scientific knowledge expands, theories about the multiverse are becoming more sophisticated, thanks to new findings in physics and astronomy. Breakthroughs in telescope technology and observational techniques are empowering scientists to study the cosmos with a level of detail that was previously unimaginable. Although direct proof of other universes remains elusive, each fresh discovery about our own cosmic home intensifies our curiosity about what may exist beyond its boundaries. Furthermore, the multiverse concept is deeply connected to cosmology and our models for how the universe began. Certain theories propose that the Big Bang wasn't a singular event, but rather one of many moments of creation occurring within the vast framework of a larger multiverse. This viewpoint completely redefines our perception of time and space, revealing them as elements of a fabric far more expansive and complex than we ever thought possible. The multiverse, with all its profound implications, encourages you to wonder and to dream. It serves as a powerful reminder that regardless of how much we've learned about the universe, an immense, uncharted territory still awaits us. Every answer we uncover simply leads to more questions, and the multiverse stands as one of the most compelling mysteries driving us to continue exploring, learning, and imagining. Ultimately, this quest is not just about understanding the cosmos, but also about deepening the awareness of your own life and the role you play in this magnificent universe. Gravity is undeniably one of the most powerful and intriguing forces in the cosmos. But have you ever stopped to think about how it shapes the structure and evolution of everything around us? To grasp its influence, you need to see gravity not merely as a force pulling things together, but as the very curvature of space-time itself. Picture the universe as a vast, taut sheet. If you place a heavy bowling ball on it, the fabric warps and creates a dip. Any smaller marbles you roll nearby will naturally move toward the ball, following the curve, which is precisely how gravity guides the paths of celestial objects. Gravity's influence extends beyond single objects. It is the master architect of the universe's large-scale structures. Consider how planets are bound together in solar systems, or how countless stars form and cohere into galaxies. These formations are all direct results of gravitational attraction. In a universe without gravity, planets would have no reason to orbit stars, and stars would lack the cohesive force needed to form galaxies. Gravity truly designs the appearance and organization of the cosmos. But what happens when you examine gravity's effects on even grander scales? As you observe the arrangement of galaxies throughout the universe, you'll find they aren't distributed uniformly. Some areas are crowded with galaxies, while others are nearly empty. This pattern isn't accidental. It's the outcome of gravity working its magic over billions of years. Regions with higher density exert a more powerful gravitational pull, attracting more matter, and forming immense galaxy clusters, as if the universe is woven together by an unseen network of threads. This same force is also behind some of the most spectacular phenomena in the cosmos, such as black holes. Imagine a star of immense mass reaching the end of its life and running out of nuclear fuel. At this point, gravity can become so overwhelming that the star collapses under its own weight, forging a black hole.
These cosmic objects are so incredibly dense that their gravitational pull prevents even light from escaping, which makes them invisible and challenging to observe directly. Yet we can detect their immense gravitational sway on nearby stars and gas, which helps us understand how gravity behaves under the most extreme conditions. Beyond black holes, gravity's power is also evident in the way entire galaxies interact with one another. When two galaxies drift close enough, their mutual gravitational pull can trigger a breathtaking cosmic performance. These encounters can culminate in galactic mergers, where the two galaxies combine to create a new, larger one. During this process, the colliding galaxies are often warped and stretched into intricate and beautiful new shapes, with gravity acting as the conductor of this celestial symphony. However, the influence of gravity doesn't end with galaxies. On the scale of the entire universe, gravity plays a crucial role in the expansion of the cosmos itself. When we think about cosmic expansion, our minds often jump to the Big Bang, but gravity is a key factor in how that expansion proceeds. It acts as a constant brake, trying to slow the expansion down, while a mysterious force known as dark energy seems to be pushing it to accelerate. It's as if the universe is locked in an eternal tug-of-war between these two fundamental forces, a battle that will determine its ultimate destiny. In a truly mind-bending twist, gravity also alters your perception of time. As described by Einstein's theory of relativity, time is not a universal constant, but can be warped by gravitational fields. In regions where gravity is exceptionally strong, like near a black hole, time actually passes more slowly compared to areas with weaker gravity. This deep connection between gravity and time is a startling reminder of how interwoven these fundamental forces are within the fabric of reality. Finally, gravity's reach extends all the way down to our life here on Earth. Without this essential force, our planet could not hold on to its atmosphere or sustain the flow of its oceans and rivers. The very way you experience the world, the feeling of your feet on the ground, the arc of a thrown ball, is fundamentally tied to the constant, unwavering presence of gravity. This fundamental force governs everything, from the simple motion of walking to the vast currents of the oceans. Gravity doesn't just sculpt the universe, it fundamentally defines the reality of our daily lives. As you consider these interactions, it's crucial to recognize that gravity is the universal tie that binds everything together, from the subatomic particles composing our bodies to the most remote galaxies. It acts as the unifying thread in the magnificent cosmic dance, serving as a reminder that even though we may seem insignificant in the immense scale of the cosmos, we share a deep and profound connection with it. Ultimately, gravity is far more than a simple force of attraction. It's an elemental power that sculpts the cosmos, steers the evolution of galaxies, and even warps our very perception of time. You can see its handiwork everywhere, from the formation of black holes to the spectacle of galactic collisions. Gravity is truly the artist that shapes the architecture of the universe. As our exploration into the nature of the cosmos deepens, gravity will always be a compelling topic that encourages us to contemplate our position within this vast expanse, reminding us that every celestial body is part of an eternal dance, choreographed by its powerful influence. The ultimate destiny of the universe is a subject that inspires a great deal of wonder and curiosity. You might ask, what will the cosmos look like billions of years into the future? While we cannot predict the future with certainty, scientists have formulated several compelling theories to address this very question. A helpful way to visualize this is to picture the universe as a balloon that is constantly being inflated. As it fills with air, it expands. The critical question, however, is just how long this expansion can continue. One of the most widely accepted theories proposes that the universe is destined to expand forever. This concept stems from the direct observation that galaxies are perpetually moving away from each other, almost as if they are in a cosmic race to create the greatest possible distance between them, resulting in an ever-widening expanse of nothingness. In this scenario of unending expansion, all stars will ultimately exhaust their nuclear fuel and burn out. As the universe simultaneously cools and grows larger, these fading stars will leave behind a dark, silent, and desolate cosmos, where a profound emptiness reigns. Yet, eternal expansion isn't the only potential outcome. An alternative theory posits that the universe could reverse course and begin to contract. Can you conceive of a cosmic cycle where, after eons of growing apart, galaxies start moving back toward one another? This is the central idea behind the Big Crunch, a scenario where the universe would deflate like a punctured balloon, crushing everything back into an infinitesimal singularity, a terrifying but fascinating return to primordial chaos. An even more bizarre possibility is the Big Rip, where cosmic expansion accelerates so violently that it overcomes all other forces, tearing apart galaxies, stars, planets, and even the very atoms that constitute reality, leaving absolutely nothing behind. While you contemplate these theories, a fascinating question emerges concerning the role of gravity in these future scenarios. Gravity, the very force that anchors you to the Earth and orchestrates the orbits of stars, is a critical player. If gravity proves to be powerful enough, it has the potential to halt the expansion and trigger a cosmic collapse. However, if dark energy, the enigmatic force driving this acceleration, maintains its dominance, the expansion will continue unchecked. The key to our cosmic destiny may lie in the answer to this cosmic battle. And with every new discovery, scientists add another crucial piece to this complex puzzle. As we venture into these theoretical futures, it's also compelling to think about the place of life itself. What might become of humanity if the universe turns cold and dark, and how would such a fate impact our existence? This is a frequent theme in science fiction, which imagines civilizations escaping to other worlds or discovering novel ways to endure in a constantly transforming cosmos. This quest for answers is more than a mere academic pursuit. It compels you to reflect on your own life and your place in the universe, raising the question of what kind of legacy we will leave behind in a cosmos that could one day become hostile to life. In these contemplations, science and philosophy become deeply intertwined, urging you to question not just the universe's ultimate destiny, but also the significance of your own life. As our cosmic exploration progresses, it is vital to keep in mind that each new solution only uncovers new mysteries, with human curiosity serving as the perpetual engine of our knowledge. While we may not possess all the answers about the universe's future, every breakthrough moves us closer to comprehending the immense and enigmatic reality all around us. Science is progressing at an incredible pace, and it is entirely possible that future generations will develop theories beyond our wildest imaginings today. In the end, considering the future of the universe serves as a potent reminder of our own delicate nature and the profound beauty of existence. Within a cosmos that might be timeless and infinite, each moment of our lives is a brief, brilliant spark against an endless backdrop. This raises a critical question for you. What will we do with the time we are given in this immense universe? The answer rests entirely with us. This relationship between humanity and the cosmos is a truly captivating subject for reflection, prompting one to wonder how it is that such tiny beings on a small blue world came to contemplate the very meaning of it all. From the dawn of our species, we have looked toward the heavens, feeling a profound paradox of being both utterly minuscule and uniquely special as we reflect on the stars. This contradiction forces you to ask a fundamental question. Is our existence simply a fluke in the limitless expanse of space,
Or does it serve a more significant purpose?
When you gaze into a clear night sky, every point of light is more than just a distant sun. It's a reflection of your own origins, a reminder that you are literally made of stardust. Every element that constitutes your body, from the life-giving oxygen you inhale to the carbon that is the foundation of your cells, was born in the core of a dying star. It is truly remarkable to realize that you are a living part of a cosmic narrative that has been in motion for billions of years. The universe doesn't just supply the raw materials for life. It also grants you a profound vantage point on your own existence. In this way, observing the stars becomes an exercise in self-discovery, prompting you to ponder what it truly signifies to be human within this immense cosmos. While science offers concrete answers, each new discovery seems to introduce even more profound questions about our own nature and destiny.
This drive to comprehend the structure of the cosmos is something that brings all of humanity closer together. A fascination with the universe is a common thread that connects us, overriding our cultural or geographical divides. We are all bound by the same innate curiosity about where we came from and where we are headed, making the cosmos a mirror that shows us our deepest collective dreams and anxieties.
Contemplating the sheer scale of space and time also reshapes how you perceive your day-to-day life and its challenges. When you compare your immediate worries to the grandeur of the universe, they often seem insignificant. This realization can be incredibly liberating, offering you the freedom to let go of trivial concerns and instead concentrate on what is genuinely meaningful: your relationships, your personal growth, and your experiences. Amid these thoughts, other powerful questions inevitably arise, such as the possibility of life existing on other worlds. The search for extraterrestrial intelligence is far more than a scientific endeavor. It is a journey to better understand ourselves. If you were to discover life on another planet, how would that fundamentally alter your self-perception and our collective human identity? The prospect of not being alone in the universe compels you to re-examine the very nature of existence, consciousness, and connection. Tremendous progress in astronomy and space exploration has revealed a universe far more intricate and dynamic than we ever thought possible. Every new finding, from the discovery of exoplanets to the detection of strange radio bursts, moves us closer to solving mysteries that have puzzled humanity for millennia. This continuous process of discovery is a powerful reminder that the cosmos will always hold surprises and challenge your assumptions. It is also crucial to recognize that this sense of wonder is not exclusive to scientists. We are all capable of being moved by the universe. Embracing our connection to this vast system can inspire you to be a more responsible guardian of our own planet for the sake of future generations. Our relationship with the cosmos also fuels a deep search for meaning, where the domains of philosophy and spirituality often overlap with scientific inquiry. Perhaps a true understanding of the universe could guide you toward a greater sense of purpose. Maybe each star is not just a ball of burning gas, but a beacon symbolizing humanity's relentless quest for truth. The narratives you create about the universe are also profoundly important. For centuries, myths and legends serve to explain the unknown, helping people make sense of their lives and find their place in the world. Today, science provides new stories grounded in observation and data, yet the underlying human desire to find meaning remains unchanged. As you look toward the future, the question of our place in the cosmos gains even more urgency. Will we ever achieve a complete picture of the universe and our specific role within it? This pursuit of answers will undoubtedly propel us beyond our solar system, toward new realities and undiscovered worlds, driven by the unstoppable engine of human curiosity. Ultimately, your relationship with the cosmos teaches a lesson in humility. In a universe so ancient and vast, it is easy to feel overwhelmed by its scale and to see our problems as trivial. Yet at the same time, it highlights the potential for each one of us to make a meaningful impact, as the way you choose to live, learn, and love can have lasting significance.
So, what recent breakthroughs have truly revolutionized your understanding of the cosmos? The answer is both thrilling and constantly in flux. As we persist in our exploration of the universe, we uncover findings that upend our previous knowledge and force us to reevaluate our position on this grand cosmic stage. Just recently, for instance, astronomers were able to detect gravitational waves produced by the collisions of black holes and neutron stars. This phenomenon, which sounds like something straight out of science fiction, gives you an entirely new sense with which to perceive the universe. These gravitational waves are like faint echoes from ancient cataclysmic events, carrying whispers across billions of light years to tell you about the universe's most violent moments.
Isn't it remarkable that our technology allows us to capture these cosmic echoes, giving us a clearer understanding of space and time? Another development that has thoroughly captivated the scientific world is the discovery of exoplanets within the habitable zones of stars, much like our own sun. Through the use of powerful telescopes, scientists have pinpointed over 5,000 of these far-off worlds. A number of them reside in what is termed the habitable zone, an area where conditions could potentially support the existence of liquid water, raising the question, could life forms beyond our imagination exist on one of them? The notion that we may not be the sole inhabitants of the universe introduces a profound new layer to our comprehension of the cosmos. Meanwhile, dark matter, an enigma that has long puzzled us, is slowly starting to give up its secrets. Emerging research indicates that this mysterious substance, which accounts for roughly 25% of the universe, might be composed of particles that have yet to be discovered. These recent inquiries have prompted scientists to speculate about new particle types that could explain the gravitational forces we witness in galaxies, making one wonder if detecting them could finally solve the dark matter puzzle. At the same time, our telescopes have delivered breathtaking images of galaxies colliding, presenting cosmic displays of light and structure that stretch the limits of human imagination. These galactic mergers are more than just visually spectacular. They provide invaluable lessons on the evolution of galaxies and the part they play in sculpting the universe. What narratives do these immense collisions hold about the cosmic past and the future that awaits? The study of dark energy, which makes up about 70% of the universe, remains at the cutting edge of scientific inquiry. This puzzling force is apparently causing the expansion of the cosmos to accelerate. New investigations have started to illuminate its true nature, proposing a potential connection to what Einstein called the cosmological constant. Could it be that this dark energy is the decisive element that will dictate the ultimate destiny of our universe? Furthermore, space probes such as the James Webb Space Telescope are now providing us with views into cosmic regions that were once entirely hidden from us. These observations have enabled scientists to examine the birth of stars and galaxies in the early universe, with the new images acting as a kind of time machine that shows us the cosmos as it was billions of years ago. Artificial intelligence is also assuming a vital role in contemporary cosmology. We now employ machine learning algorithms to sift through immense volumes of astronomical data, identifying patterns that a human observer might easily miss. This partnership between human intellect and AI allows us to process information at an unprecedented speed, revealing new correlations in the behavior of galaxies and dark matter. What unforeseen breakthroughs might arise from this synergy between people and machines? An equally thrilling field of research is the ongoing search for signals from technologically advanced civilizations.
Initiatives like the Search for Extraterrestrial Intelligence, or SETI, utilize state-of-the-art technology to survey the heavens for any transmissions that could signify the presence of intelligent life elsewhere. With every technological leap, the prospect of detecting such a signal grows more realistic. What would such a discovery mean for how we perceive our own place in the grand scheme of the universe? We have also confirmed the existence of supermassive black holes residing at the cores of almost every galaxy. These cosmic titans are instrumental in galactic dynamics and the overall evolution of the cosmos, and each new observation teaches us more about their conduct and their influence on large-scale structures. Finally, the field of quantum cosmology is starting to merge with our broader understanding of the universe. This convergence of quantum mechanics and general relativity is forging new paths of inquiry that could completely reshape our perception of reality. With every step forward in this discipline, we inch closer to solving the most profound mysteries of existence. What incredible revelations are waiting for us just over the horizon of physics? Ultimately, the cosmos is a realm filled with wonder and enigmas, where each new piece of information beckons us to venture deeper into the unknown. As we forge ahead in our pursuit of knowledge, we not only gain a better grasp of the universe that surrounds us, but also discover more about ourselves in the process. It is human curiosity and our inherent need for answers that fuel this relentless drive to explore and to understand. The future of cosmology holds the promise of being just as riveting as the discoveries we have already made. The sheer scale of the cosmos is a mystery that compels you to think deeply. And as we have examined the shape of the universe, we have faced questions that test the very limits of our understanding of being. During this exploration, you have likely realized that the shape of the cosmos is more than a mere subject of scientific investigation. It is fundamentally woven into our own human narrative. Every insight we gain unveils another fragment of the cosmic puzzle. From the sheer immensity of the observable universe to the captivating theories that try to account for its origins, you can see how each answer inevitably spawns a new set of questions. The connection between all this and our daily lives is far more profound than it first appears, as the very laws governing the universe also dictate our perception of time and space. Consider for a moment the expansion of the cosmos. The realization that the universe is not only growing, but that its distant parts are receding from us is truly mind-boggling. This continuous motion serves as a reminder that we are never static, not even for an instant. It leads us to question whether we might one day reach the edge of the universe, or if something will always lie beyond our sight. At the same time, the large-scale structure of the cosmos, with its intricate web of galaxies and clusters, reveals an astonishing degree of organization amid this perpetual expansion. But what is the reason behind the distinct clustering patterns we observe in galaxies? The pursuit of this answer could illuminate the nature of invisible forces, like dark matter and dark energy, which comprise the vast majority of the cosmos. Although they are imperceptible to us, their existence is undeniable, shaping the very structure and evolution of the universe, and holding secrets we have yet to grasp. Another captivating mystery is the very geometry of the universe. Is space fundamentally curved, perfectly flat, or does it possess a form beyond our current imagination? This isn't merely a mathematical puzzle. It carries profound philosophical weight, as the shape of space itself could dictate how we interpret reality. Are we destined to one day comprehend the true architecture of the cosmos?
The quest for these answers draws us into the most intricate theories of modern physics. As you delve into the study of black holes and the life cycles of stars, you find that these phenomena are not just fascinating subjects, but are also central to forging the elements that constitute our world. It's possible that when you gaze into the night sky, you are, in a sense, looking at parts of yourself, as every star has lived and died, contributing its substance to the matter from which we are all formed. Cosmic cataclysms, such as the collision of entire galaxies, reveal a universe in a state of perpetual flux. What does this constant transformation imply for the stability of everything we know? The story of the universe's evolution is one of relentless change, and perhaps there is a crucial lesson in this for us. When faced with change in our own lives, do we react with fear, or do we learn to embrace it? The formation of planets and the ongoing search for life beyond Earth represent vital frontiers in our cosmic exploration. The mere possibility of other habitable worlds forces you to confront humanity's potential solitude in the vastness of space. Are we genuinely alone, or could there be other civilizations gazing back at us from their own unique perspectives? The answer could fundamentally redefine our definition of life itself. Venturing into concepts like string theory and quantum cosmology, you start to perceive the universe as an intricate web of profound interconnections. Could it be that all the fundamental forces are woven together in ways we are only beginning to decipher? With each new scientific breakthrough, we edge closer to unraveling the breathtaking complexity of existence. The idea of the multiverse extends this complexity, inviting you to envision a reality filled with countless parallel universes, each governed by its own distinct laws and possibilities. What would it mean if our existence was just one of countless variations? This concept profoundly challenges our sense of uniqueness and prompts a deeper questioning of the nature of our own reality. Of course, the influence of gravity on the shape and evolution of the universe is undeniable. From the simple fall of an apple to the intricate dance of the planets, gravity is the universal force that holds everything together. Its impact on our daily lives is so constant that we often forget we are perpetually immersed in its embrace. But what if gravity's strength hasn't always been a constant throughout cosmic history? Ultimately, contemplating the future of the universe forces you to confront questions about our own destiny. What will the cosmos look like in 1 billion years? And are there scenarios where humanity might survive and even flourish within an ever-evolving reality? These thoughts compel you to appreciate the present moment and to value the time you have as an integral part of this grand cosmic story. The deep connection between humanity and the cosmos is a common thread that unites us all. As you continue to probe the universe's mysteries, remember that every discovery not only deepens our understanding of space, but also reveals more about who we are. The search for knowledge is an endless journey, and every one of us is a participant in this magnificent adventure. So let's keep asking questions, nurturing our curiosity, and marveling at the infinite expanse that surrounds us.